Hello, everyone. We're going to be talking about a specific type of confidence interval called the one sample Z interval for P. This is a follow-up to our previous lesson. So it's going to involve the same calculations and other things that we write up about confidence intervals. Now we're just going to put it all together. So the first thing is there's quite a few things that you have to check off when we're doing these type of questions. And they're always going to say something like construct and interpret a 95% confidence interval for the true proportion of something. Um, it doesn't have to be 95%, it could be any sort of percent that the confidence level is set at. There's a few things we want to check off that we make sure we're doing. We want to make sure we're naming the procedure. So in this case here, we have the name. It's the one sample Z interval for P. We want to define what the parameter is. So the true proportion of whatever we're doing in context of the problem. We want to check our three conditions. Remember, it's the random, 10%, and large count conditions as we did before in our previous lesson. Perform our calculations either by hand or we can use the calculator's commands, and I'll show you both ways. Just a little bit warning on the calculator commands. You're likely not to get partial credit using those. So you got to make sure you know what you're inputting on there if you want to get full credit. And then for your conclusion is always going to be the interpretation of the confidence interval. So we are 95% confident that the true, and then we finish the rest of that interpretation. So let's look at a problem in practice. Remember, on our formula sheet, you are given this. You are not given this. You are provided the standard error formula, but not the entire interval. So you have to know what we're kind of putting around it when we're doing our calculations. So these type of questions usually have one or two parts. In this case here, let's read through the example so we can see the two parts. A recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. And part A says instruct and interpret a 95% confidence interval for the proportion of all cell phone users who admit to walking into something or someone while talking on their cell phone. Part B says interpret the confidence level. Now, part A is the bulk of your work here. When it says construct and interpret, this is where you're following those procedures to get all the things that checked off the list here. The last part's going to usually be a follow-up question. In this case, it's interpreting the level. We have a template for that as well. So let's talk about the first thing we do. We want to name the procedure. Well, the name of this procedure is one sample Z interval for P. It's the only thing we've studied so far, so this is kind of the only thing you have to work with. And then what is the parameter we're trying to define? So we're talking about the true what? This is what we're trying to estimate here. So it's the true proportion of cell phone users who admit to walking into something or someone while on the phone. You can paraphrase that, but make sure you use context on that. So I'm going to write context here. And don't use p hat, use p because we're estimating the true proportion. So it's the parameter, not the statistic. Parameter, not the statistic. So it's going to be the true proportion, not the sample proportion. Sometimes this part's called the state. So if you open a textbook, it might say like the state part. So we're naming our procedure and our parameter. I want to make sure that we identify procedure and parameter. So I'm putting those both as P and P. But the next part we want to do is check our conditions. We've done this before in our previous lesson. So it's the random, the 10%, and the large counts. So we have our random condition. We just want to make sure we repeat that. So we can paraphrase 738 randomly selected cell phone users as stated in the problem. We're going to assume in this case that that's going to be less than 10% of all cell phone users. We're not told how many cell phone users there are, but I'm sure there are billions in the world. And the large counts, well, we want to make sure our large counts, our number of successes and failures is at least 10. Remember, this satisfies the approximately normal condition and allows us to use a normal curve to make these estimates. Now, remember that we have to have the number of successes n times p hat. Well, we're not given p hat. We're given the number of successes from this problem. So that's literally 170. So 170 of the respondents admitted to walking into something. That's going to be your n times p hat, which means that your number of failures would be the difference between the 738 here and the 170. That's going to be how many are left over. Now, as you can see, both of those are going to be equal to 10. So we've met our large count conditions, but we got to write that out And sometimes the textbooks will call this the plan part. So this is the conditions. The last part are usually the easiest part, and we just want to do the calculations. I say the easiest. It's going to look difficult at first because I'm not going to show you any shortcuts. But for our calculations, remember, we're only given the confidence interval generic formula. And so that first thing, that statistic is our sample proportion. Well, what are we looking at? We're looking at 170 out of 738. So we're going to divide those in our calculator. We'll get a decimal. You can round it to a few decimal places if you want. I'm going to say that's so close to 23% that I'll just say 0.23. Next thing is our critical value, and that has to do with your confidence level. And remember in our previous lesson, we are showed you how to get the critical value there. So if you're not sure, follow the previous lesson or the videos posted, and you'll see how to get that 1.96. The standard error formula on your formula sheet is provided. Remember, it's right over here. It's p hat 1 minus p hat over n, all under the square root. So since we have our p hat and we have our n, remember n is our sample size. That's going to be 738. We can plug all of those into the formula. So I just rounded it 23%. So 0.23 times 1 minus 0.23 over 738 under the square root. And carefully use your calculator. You're going to get about 1.55%, so 0.0155. So the next thing we're going to do is going to put it back all together in the formula. And so you'll have your statistic 0.23 plus or minus your critical value, which is going to be that 1.96 times your standard error, which is 0.0155. Next, I want to calculate the critical value times the standard error, and that's going to give you your margin of error, which is about 3%, give or take. So it's a little bit off of 3%, so I'm rounding to 3% here. And so your final interval will be 0.23 plus or minus 3%, so 20% to 26% approximately. That's your calculation. Now, let me show you how you can get those values using your step menu in your calculator. You can get this interval, and a lot of times on the scoring rubric, they're only asking for the correct interval. Now, if you make some minor calculation errors in here, you might be able to eke out partial credit if you show your work. On your calculator, you're not going to get partial credit, but if you know the correct inputs, you can get everything in there correctly. So what you'll do is you'll open up your calculator and you're going to go to Stat, go to Tests, and your calculator calls this the one prop Z interval. It's one samples Z interval for P, so one proportion Z interval. So the X represents the number of successes. In this case here, it's going to be 170. So we're going to put 170 on top. And then N is the sample size. So our sample size is 738. So we'll put the 738 there. And then you'll set your confidence level. And the default level on your calculator is 95%, which is the most common one. So since ours is 95%, we don't have to change it. Go down to calculate, and it'll give you the interval. So it'll be rounded to sometimes 3, 4, 5 decimal places, depending on how the calculator rounds it. In this case here, I said about 20 to 26%. And our calculator says 19.997% to 26.073%. So really close by hand that we got it. This p hat is your sample proportion at about 23%, and it gives you the sample size. So everything is in there. And if you write all of this information down, saying you used your calculator, one proportions interval, you can get credit for this part, but you have to put it in correctly. And so here are the screenshots again, if you want to write those down or take a screenshot of that. And finally, the conclusion. Well, remember, we have a template for that, so we're always going to interpret the confidence interval in context of the problem. So remember, we have this template. We are blank percent confident that the interval from this to this captures the true parameter in context. So in this case here, we have our 95%. Our interval was about 20 to 26%, so 0.2 to 0.26 captures the true. And remember, we're talking about cell phone users who admit to walking into something or someone while talking on the cell phone. So we're going to put that context in there, and that's going to be your conclusion. And then the textbook will call this the conclude. So the textbook says state, plan, do, conclude. I'm a procedure, parameter, conditions, calculations, conclusions. So I like to use those 5 things to remind us to have everything on there. A lot of times there's a follow-up question to these. So in this case, it says interpret the confidence level. Remember, level's different than interval. We have a level template we used in our last lesson. Here's a reminder what that looks like. If we were to select many random samples of the same size from the same population and construct a blank percent confidence interval using each sample, about same percentage of those intervals would capture the true parameter and context. I do paraphrase this a little bit. I say if we were to repeat this process many, many times, about blank percent of the confidence intervals we construct would capture the true parameter and context. So a little bit less writing because it's already kind of a lot to write the level. So it's 95%. And then 95% of those confidence intervals we construct would capture the true proportion of cell phone users that admit to walking into something while on the phone. So it's a lot going on this. So you have one, check your understanding, and you're going to want to pause this video and try it on your own. So let's read the question. Sleep Awareness Week begins in the spring with the release of the National Sleep Foundation's annual poll of U.S. sleep habits and ends with the beginning of daylight savings time, when most people lose an hour of sleep. Excuse me. In the foundation's random sample of 1,029 U.S. adults, 48% reported that they often or always got enough sleep during the past 7 nights. Part A says construct and interpret a 90% confidence interval for the proportion of all U.S. adults who would report often or always getting enough sleep during the past 7 nights. And then part B is the follow-up question. In this case, it's asking if the interval provides convincing evidence. So convincing evidence that fewer than half of all US adults would report they often or always got enough sleep during the past 7 nights. Justify your answer. So try this question on your own. Follow those 5 steps, and we're going to go through it in 3, 2, 1. Here we go. So the first thing is we want to make sure we list out the things we're going to do. So we're going to name the procedure, identify the parameter, check the conditions, the calculations, and do our conclusion. So anytime you see construct and interpret, that's what you're doing over here. So the procedure is the one sample z interval for p. This is the only thing we've learned so far. The parameter is the true proportion of, what are we measuring? US adults who report getting enough sleep during the past 7 nights. In our conditions, random, 10%, and large counts. So our random sample of 1,029 adults, that's right here. Our 10% is, we're going to assume 10% of, less than 10% of all US adults were sampled, and which is almost always going to be the case here. In our large counts, we don't have the number of successes. We're actually given the sample proportion. So this 48% is actually your p hat. I'm going to write that down here. So since we're trying to calculate that, remember we do n times p hat, and we do n times 1 minus p hat. So we actually have to do 1,029 times 0.48 and 1,029 times 1 minus 0.48. Don't worry about rounding those. You can round up or down if you want, but we just want to make sure that those are at least 10, which they are. So we've checked all 3 of these. We've met our conditions. And the last 2 steps are the calculations and the conclusion. So the calculations, remember our sample proportion is 48%. Our Z star is a 90% confidence interval, so you can calculate that at 1.645. Plug it into your standard error formula. So the square root 0.48 times 1 minus 0.48 over your sample size, 1029. You'll get about 1.56% or 0.0156. And then you can put it all into the formula. So 0.48 plus or minus 1.645 times 0.0156. Use your calculator and you'll get about 2.57% for your margin of error. And then you can go below and above it to get your final interval, which is about 45.4% to 50.6%. Notice I highlighted the interval over here because that is how you want to write your interval at the end. Your conclusion is going to be, we are, and what's our percentage? Well, we're 90% confident. So 90% confident that the interval from this number to this number captures the true parameter and context. So 90% confident that the interval from 0.454 to 0.506 captures the true, and we're talking about proportion of all US adults who report always getting enough sleep during the past 7 nights. Often or always, but I paraphrase it a little bit. So proportion of US adults who report getting enough sleep during the past 7 nights. And that takes care of that part. Here's your calculations again. Again, I'll walk you through the calculations on this one. This is a little bit trickier. You got to remember some things about the calculator on this one. So remember that when you do your inputs on this. We're not putting a percentage. We're actually putting in the counts. So it's like our top number is going to be your number of successes. So it's like 48% of 1029. Well, you can do that by multiplying 0.48 times 1029. And you get 493.92. You remember your large counts from before. That's one of those large counts. Now your total sample size is 1029, so we put that over here. And if you do your confidence level at 90%, I believe it was set at 90%. If you do it like this, it's going to give you an error because it doesn't allow you to put decimals into there. So you have to go back and round to the nearest whole number. So 493 is not going to be allowed. You have to put 494. And it's not going to do the rounding for you. So put them in like that, and then you get your confidence interval, 45.4% to 50.6%, which is exactly what we got. Well, actually, it's more precise than what we got, to be honest, because the calculator will give you no rounding errors. So that'd be the preferred number to put in using your calculator. Just don't make any input mistakes and it'll be fine. So you can use your calculator if you want for the do. And then finally, does the interval provide convincing evidence that fewer than half of all US adults would report they always got enough sleep during the past 7 nights? Well, what is fewer than half? That's going to be less than 50%, right? So if you look at the interval, yeah, there are plenty of numbers less than 50%, but also there's a number at 50% and above, 50.1%, 50.2%. So I don't have convincing evidence that fewer than half because there are values at 50% and above in the interval. So the interval does not provide convincing evidence in this case. All right, that's going to conclude this video. The next video will talk about how to adjust the margin of error and find a sample size. Thanks for watching.